Welcome back, section 7-1. This is going to be part 2 of this topic where we'll actually start to look at how to add and subtract polynomials, which you should have a little bit of knowledge of already based on just the talk about combining like terms. So we talked about different types of polynomials we have, what a polynomial is, the three specific types, monomial, binomial, and trinomial, how we distinguish between terms, what terms are separated by either a plus sign or a minus sign. So we'll start to get into looking at how to combine like terms today. So combining like terms, big things here. In order to add or subtract, our like terms must follow these conditions. They have to have the same variable and they have to have the same exponent. So over here to the right, you'll see we've got 3x to the first and 2x squared. So these two terms both have the same variable. They both have the variable x. That's great. The problem here is that one has a power of 1 and one has an exponent of 2, which means these are not like terms. Oh gosh. Okay, these are not like terms because they have different exponents. Okay, now if I were to sit there and take my little eraser and go like that, and go like that, now they are like terms. 3x plus 2x. What would you have? You'd have 5x. Okay, we don't add the exponents together. We don't add the x's together. It's the coefficients out in front. Okay, it's this stuff right here. I'm going to add the 3 to the 2. It's like if somebody gave you 2 Oreos and then a friend gave you 3 more Oreos. You don't have Oreo squared. You just have Oreos. You got a total of 5 Oreos. So that's pretty much how it works. All right. So these are like terms. So I can delete that. All right. Only add or subtract the coefficients, not the exponents. See, look at that. Just what I just said a second ago. So you might hear us talk about standard form. Standard form basically means this. In your answer, you want to start with the highest degree term. Okay. And then go all the way down to the lowest degree. And whatever the coefficient is in front of the highest degree term, we call that the leading coefficient. So here, x cubed is my highest degree, so that goes first. And then we go to the next lowest, and the next lowest, and then the very lowest at the end. The number in front of the highest degree term is called the leading coefficient. All right, so in part A here, we just want to write these in standard form. So in part A, which of those 3 terms should go first? Yes, that's right. Here we've got x to the 5th, so 4x to the 5th should go first. What would go next? That's correct. The 3x squared would go next. Good. And then that means the 7x would stay at the end. Now notice the 7x has a minus sign in front of it, so that minus sign has to stay with the 7x. And so if we reveal our answer then, boom, 4x to the 5th. Okay, this is positive because it had a plus sign in front of it. There's no negative, so it stays positive. The 3 was positive, which is why we put the plus sign in front of it. And then like we said, the minus sign stays with the 7x. So look at part B here. And what do you think goes first? Remember, you want the greatest degree. In this case, we're looking for the highest exponent. Yep, our 2y to the 4th. That's going to go in front, followed by the 6y cubed. Good. And then 5y. Excellent. And then our minus 9 will go at the end. Okay, anytime you have a constant, more than likely that's going to be at the very end of your answer because there's no variable, which means it has a degree of how much? That's right, 0. Very good. So here's what our answer would look like in standard form. So notice the sign in front of the term stays with that term. Minus sign in front of the 6 stays there. 5y was positive, that's why we've got a plus sign here. And the minus sign with a 9 stays with a 9. So That's how we put things in standard form. So how do we actually start to solve these problems in terms of adding and subtracting? All right. So number one, you've got 1, 2, 3 terms. This is a trinomial. 1, 2, 3 terms. This is a trinomial. So you want to combine the terms that look the same variables and same exponents. So you'll notice here in this case, I've kind of color-coded it for you to help you out to start. So our x squareds will go together first. So 3x squared plus a negative 7. Our x's will go together, negative 4x plus 2x, and then 8 plus negative 5, or we just say 8 minus 5. So when you put all those together, we end up with this answer. So 3x squared minus 7x squared is negative 4x squared. Negative 4x plus 2x is negative 2x, and then our x at 8 minus 5 should be plus 3. So in number 2 here, notice that we really don't have here CD. We need another term that has CD with just a power of 1 on both the C and the D. I've got CD here. Is that the same? No, it's not, because here D has a power of 2, while over here D only has a power of 1. I've got D here, but this D has a power of 2, so those are not the same. So we don't have any like terms in this problem whatsoever. So what do? We simply rewrite the problem, and you just try to do it in the best manner possible. So here I just wrote that one, the first trinomial, wrote it down, and then wrote the next trinomial in front of it. Notice here, I don't put plus a negative 6. That's a plus sign, that's negative, so that just becomes a minus 6. All right, so you can do that. Would it matter if you had this in a different order? Not really. All right, so here's a couple for you to try. Hopefully you've written these down already in your notes. If not, I'll just kind of show it and then give you a second, or pause the video. Welcome back. So again, I've done a favor here for you and kind of highlighted the like terms. So hopefully you came out with the answer of 12y squared minus 2y minus 1. So here our degree would be 2, because that's the highest power out of all 3 terms. Now subtracting can get tricky. So here's the big tip I'm going to give you. Anytime you've got subtraction between two different sets of polynomials, my advice is put a 1 in between the minus sign and the parenthesis, and then just distribute the negative 1. Okay, so this first one doesn't change. I would leave that the same. The second one here, negative 1 times 7n, negative 7n. Negative 1 times 4n cubed, negative 4n cubed. So we're going to be subtracting 7n and subtracting 4n cubed. Notice I did the same thing over here. Put the 1 in front, in between the minus and the parenthesis, and now we just distribute. So 2ab squared times negative 1, negative. Positive times a negative, negative. Negative 8ab times negative 1 gave us positive 8ab. So that's my biggest advice to you. If you're subtracting there, put that 1 in between the minus sign, the parenthesis, and then just distribute. So now it's just a matter of collecting your like terms, which again, I've color-coded to hopefully help you out. And we see our answers as we go forward. So hopefully those will make sense. Now here, ab squared, degree of 3, degree of 2, degree of 3, because you got the 2 and the 1. So what's our degree of this one? Well, this had 3, and this had 3, so since there's a tie, it doesn't matter, it's still the highest power. So this would have a degree of 3, just like this would have a degree of 3, because it's the highest degree within each of our 3 terms. So let's try these last 2 on your own. Again, I would distribute here and over here as well. If you want to pause the video, try it out, go. Welcome back, and here's what our answer should look like. So hopefully this will make sense to you in terms of combining like terms and distributing. These are all things that we've done in the past. All right, try to get your answers in order from highest power to lowest power when you can. Okay, if you have any questions, email me, let me know. Sorry, this one went a little long, but we'll talk to you soon.